Hello everyone, I am Harshavardhan from group G604. Today I am going to present my project Chest X-ray Reasoner. So, the project focuses on using artificial intelligence to help doctors read and understand chest X-ray easily, along with clear explanations for the results. Let's look at project overview. Chest X-ray Reasoner is an AI model that helps doctors by analyzing chest X-ray images and giving step-by-step reasoning for its diagnosis. It was fine-tuned from a model called Text Agent using real X-rays and doctor reports. The model not only gives a diagnosis but also explains how it reached that results. It has three main parts: interface layer, application layer, and data layer. It was trained on the Indiana University chest X-ray dataset and provides more accurate, reliable results compared to normal AI model. Now let's look at final architecture diagram. In first milestone, we started with Quen model, but it was more difficult to fine-tune and integrate compared to text agent. Quen required higher GPU memory, complex processing, and did not give medical specific reasoning outputs as clear as text agent. So we later switched to text agent, which was lighter, faster, and gave better medical reasoning results. Now let's understand the working structure. So the system is divided into three main layers. First is interface layer. This is where the user interacts with the system. Doctor or users upload X-ray images and get the results through the React frontend. Second is application layer. This is brain of the system. It uses fast API to send the user's image to the AI model, checks agent. It processes the image and returns a reasoned diagnosis. Now let's look at third layer. It is data layer. This layer stores and manages data. It uses Google Drive and Hugging Face to save model weights and datasets. Now let's look at technology stack and tools. We use Python programming language. It is used to build and train the model. For frameworks and libraries, we use PyTorch for model training and fine-tuning, and we use Hugging Face for loading pre-trained models like TextAgent. For front-end, we use HTML, CSS, React.js. It is used for web interface to upload X-rays. For backend, we use Fast API. It handles communication between the user interface and AI model. Coming to storage, we use Google Drive. It is used to store X-ray images and model weights, and we didn't use any database. For development tools, we use VS Code and Google Colab. It is used for coding and GPU training support. Now let's look at mathematical foundation. In supervised fine-tuning, there are two formulas. One is gradient descent and next is cross entropy loss. So in gradient descent, the model learns by checking how wrong it is and then updates its parameter to reduce the error. Now, theta is model parameters, means what the model learns. Eta is learning rate, means how big a step the model takes to improve. Delta L is gradient, means the direction of the error. Each time the model makes a mistake, it adjusts slightly to become more accurate next time. Now, loss function. It helps the model to measure how wrong it is. L is total loss, means how much error the model made. Summation means adds up the errors for all prediction. P of yi, it is a probability of predicting the correct answer. And the log makes big mistakes count more. So if we come across the prototype of our project, here it appears if we enter a text like do I have any abnormalities, and if you submit it, it shows a pop-up message like please upload a chest X-ray before submitting. This takes up to app.js where this part of the code handles the submit button. It sends an alert message if we submit only text or an image. It says to submit both at a time. If the submit is true, we can submit it. So here this part of the code, using the post method, we can use an API called grok, API called fast API. We can send the information through this, and after this we can download the report by using the download button at this point. Now let's look at improvements on the paper. In key learnings, we learn how ngrok and Flask work for backend connections and API setup. In improvements, we fine-tune checks agent to make it capable of reasoning like real doctors. In real-world applications, the model can be extended to CT scans and MRI scans for broader medical use. When comparing with paper results, we solve the issue of hallucinated reasoning. It makes our model's explanation more realistic and accurate. And coming to performance analysis, we achieved higher reasoning quality compared to base checks agent model. And the challenges we faced are while connecting the Flask backend API with the React frontend, and long training times and frequent collab disconnections during fine tuning. Coming to limitations, the model requires high GPU memory, reasoning accuracy can still be improved, and needs more real world testing for better reliability.